Hi guys, let's start a new chapter. The new chapter is called Solution of Right Triangles. Now this chapter has no new concept but delves on the old concept that we've done and then works on the same. So let's quickly revise the concept that we talked about in this chapter. One is called Pythagoras theorem. Pythagoras theorem obviously is applicable only for a right angle triangle, which says hypotenuse square is equal to side 1 square plus side 2 square. So there are two remaining sides. Obviously, the side opposite the right angle is known as the hypotenuse. So in this case, AC square would be equal to AB square plus BC square. We've been doing Pythagoras theorem forever, at least for the last 3 years. Next, it involves the 6 trigonometrical ratios that we've done in the previous 2 chapters. So it depends on the reference angle. So in this case, if my reference angle is A, then there are 3 sides: AB, which is known as the base or also known as the adjacent. The side which is BC, which is opposite to the angle A, this is known as perpendicular or the opposite. And obviously the side opposite right angle is known as the hypotenuse. So 6 ratios that we get are sine A, the reference angle is A, is perpendicular upon hypotenuse, also known as opposite upon hypotenuse. In this case, it would be BC upon AC. Cos A is equal to base upon hypotenuse, also the adjacent upon hypotenuse, in this case AB upon AC. Tan A, the third ratio, is perpendicular upon base. Perpendicular is also known as opposite, base is also known as adjacent. So in this case, BC upon AB. The other 3 are the reciprocal relations of the first 3. So cosec is reciprocal of sine, sec is reciprocal of cos, and cot is reciprocal of tan. So these are the 6 ratios, and then we talked about the angles, which is trigonometrical ratios of standard angles. We've done this table. We learned how to derive this table, which is write 0, 1, 2, 3, 4, divide everything by 4, and then take the square root. So the first value that you will get would be the sine. So 0 by 4, 0, 1 upon 4 square root is half, 1 upon root 2, root 3 upon 2, and 1. If you want to go from sine to cos, write the values of sine in the reverse order, which means 1 root 3 by 2, everything in the reverse order. If you want to get tan, divide sine by cos. So tan is equal to sine upon cos. And then these remaining are the reciprocal ratios. Let's look at some questions and the chapter will become even more clear. So let's look at question number 1, part 2. It says find x, and we are looking at the reference angle as 30 degree here. So let's give it some names so that it's easier for us to work with which sides we're looking at. So if this is my reference angle A, then I have this as the opposite and this as the adjacent. So which means I will look at the value of tan. So tan A would be equal to BC upon AB. In this case, tan 30 degree would be equal to BC, which is given as 20, and AB, which is given as x. Tan 30 degree is 1 upon root 3. So 1 upon root 3 is equal to 20 by x, which means x is equal to 20 root 3. This is my final answer. If the question wants you to write it in the form of a decimal, then you will have 20 into 1.732, which would be equal to 17.32 into 2, which is 34.64. So the value of x is 34.64. Done. Let's look at the next question. Next question we do is question number 2, part 1. It says find angle A. So if I take these reference points as P, Q, R, then I have the sides that I'm looking at for this. This is the base or the adjacent, and this is the side which is opposite the right angle, which means this is the hypotenuse. So we have base and hypotenuse, which means we're looking at cos. So cos A is equal to, in this case, PQ upon PR. In this case, this is given as 10 upon 20, which is half. Now, which value of cos is half? Cos 60 degree. Now, since cos 60 degree is equal to half is equal to cos A, therefore A is equal to 60 degree. So this is a combination of what we did in our previous chapter, which was trigonometrical ratios of standard angles. Let's look at question number 2, part 3. Again, we need to find the value of angle A. So if this is P, this is point Q, and this is point R. So for this reference angle, we are looking at opposite or perpendicular upon base or adjacent, which means we are looking at tan. So tan A would be equal to QR upon PQ. In this case, QR is given equal to 10 root 3 and PQ is given as 10, which means tan A is equal to root 3. Now, which value of tan is equal to root 3? Yes, tan 60 degree is equal to root 3. So since tan 60 degree is equal to root 3 is equal to tan A, therefore A is equal to 60 degree. So that's the correct answer. Let's look at the next one. The next question that we do is question number 3. It says find angle X. So we need to find this angle X. Let's give them some names: A, B, C, and D. So if I need to look at angle X, it is a part of the right triangle ABC. But in the right triangle ABC, I don't have any other information available. I have only the hypotenuse available. So let's first try and find the value of AC from the second triangle ACD. So in right triangle ACD, if this is my reference angle, AC is adjacent and this is opposite. So what we have is tan 60 degree is equal to CD upon AC. So tan 60 degree is equal to root 3. Yes, so root 3 is equal to CD, which is 30, upon AC, which we don't know, which means AC is equal to 30 upon root 3. Let's rationalize, which means multiply it with root 3 and root 3. So this is AC is equal to 30 root 3 upon 3. This is 10. Therefore, AC is equal to 10 root 3. Now that we've got the value of AC, let's try and apply it in this right triangle ABC. So in a right triangle ABC, AC would be for this triangle, this would be for reference angle X. This is not adjacent, this is opposite. For reference angle X, this is opposite and this is hypotenuse. So we are looking at opposite upon hypotenuse, which is sine. So sine X is equal to AC upon AB. In this case, 10 root 3 upon 20, which means root 3 upon 2. Sine 60 is equal to root 3 upon 2. So since sine 60 degree is equal to root 3 upon 2 is equal to sine X, therefore X is equal to 60 degree. So we had to apply it 2 times. First for the right triangle ACD, that helped us to find the value of AC, and then we applied trigonometrical ratios in the right triangle ABC. Let's look at the next question. The next question that we do is question number 4, part 1, where we need to find AD. So this is 10 meter, which means this would also be 10 meter because BCDE is a rectangle, because 3 angles are 90 degree, which means BE will be equal to 50 meters. So let's just write this down. Point number 1, quadrilateral BCDE is a rectangle since 3 vertex angles are 90 degree. What this means is point number 2 for us, which means DE is equal to BC is equal to 10 meter, and this also means that BE is equal to CD is equal to 50 meter. So this is 50, this is 10. Now we need to find the value of AE, and the reference angle here is 45. So for this is opposite and this is adjacent, which means we're looking at value of tan. So tan, before that let's specify which triangle we're looking at. So in right triangle ABE, tan 45 degree is equal to AE upon BE. Tan 45 degree is 1 is equal to AE upon 50, which means AE is equal to 50 meter. Therefore AD is equal to AE plus DE, which is equal to 50 plus 10. Therefore AD is equal to 60 meter. Done. That's what our question was. We divided this big figure into two small parts. ED we calculated using the rectangle property, and AE we calculated using trigonometry. Let's look at the next question. The next question that we do is question number 4, part 2. It says find AD again. So this is the reference, this is the side that we need to find, and the hypotenuse of the bigger triangle is given, and in the small triangle no side is mentioned. But what has been mentioned is that BC and AC are equal, which means this is an isosceles triangle, which means this is X, so this is also X. This is 60, which means this would be 120 degree, which means so this is 180, which means I have 60 more, which means this is 30 degree and this is 30 degree. Now I can calculate some values if possible. This is 100. Let's try. Okay, so I need to calculate this. So in triangle ABC, point number 1, BC is equal to AC. Therefore triangle ABC is isosceles. What this means is, therefore angle ABC is equal to angle BAC is equal to X degree. Next, point number 3 would be angle ACB is equal to 180 degree minus 60 degree is equal to 120 degree. Reason is this is a linear pair. What it means is, therefore angle ABC is equal to angle BAC is equal to 180 degree minus 120 degree upon 2. So this is 30 degree. So now let's look at the big triangle ADB. I need to find AD. This is for reference angle X here 30 degree. This is the opposite and this is hypotenuse. Right. So in right triangle ABD, what we have is sine, right? Yeah, opposite upon hypotenuse. So sine 30 degree is equal to AD upon AB. Sine 30 degree is equal to half. So half is equal to AD, which we need to calculate. AB is given as 100, which means AD is equal to 50 meter. Done. So again we use certain properties of triangle that we knew earlier. We calculated this using linear pair, and then using the angle sum property we calculated these two angles, and then finally we took the value of sine for my reference angle P. Let's look at the next question. The next question is question number 5. It says find the length of AD angle ABC is equal to 60 degree. Okay, so for the big triangle ABC is 60, for the small triangle DBC this is 45, and the base BC is given as 40 centimeter. We need to calculate the length of AD. So AD, which is this, would be equal to, so AC minus DC would be equal to AD. So first we can calculate the length of AC. The reference angle is 60 degree. This would be opposite or perpendicular, and this would be base or adjacent, which means we're looking at tan. So in right triangle ABC, what we have is tan 60 degree is equal to AC upon BC. Tan 60 degree is equal to root 3. So root 3 is equal to AC, which we don't know. We will calculate. BC is 40, which means AC is equal to 40 root 3 centimeter. Next, let's look at the small triangle. So in a right triangle DBC, what we have is tan 45 degree is equal to DC upon BC. We know tan 45 is 1, which means DC is equal to BC is equal to 40 centimeter. So this is 40 and the AC is 40 root 3, which means we need to calculate the value of AD. So AD would be equal to AC, which is 40 root 3 minus 40 centimeter, which means AD is equal to 40 root 3 minus 1 centimeter, which is 41.732 minus 1 centimeter, which means 40 into 0.732 centimeter. So that's 732 into 4, that's 8, 4 into 3, 12, 28 plus 1, 29. That's 40, which means 7.32, which means 29.28. So this is 29.28 centimeter. So that's the value of AD. That brings me to an end of this video. Before I leave, let me mark some homework questions for you. Question number 1, part 1 and part 3. Question number 2, part 2. And yeah, that's about it. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.